So we did crude oil and petroleum, and I told you that the black substance that you obtain from the Earth's crust, that is a mixture of many different things. Okay, so it's got lots of compounds, some big, some small. Okay, तो उसमें था कि जो बड़े होंगे, the bigger ones, larger molecules, they've got higher boiling points, so वो they condense very quickly, and the smaller molecules, they've got lower boiling points and they're more flammable. तो smaller वाले जो छोटे वाले ना, they're more useful. तो आप क्या करते हो, क्रूड ऑयल को वेपराइज करते हो, you pass the vapor. So higher boiling point things, large molecules, they condense very early. You obtain them as residues at the bottom. That's bitumen. कुछ vapors थोड़ा सा ऊपर जाके, when they cool down, they condense. Petroleum jelly waxes. The vapor goes further up. And something else, it cools down, something else condenses. Then it keeps cooling down, things start condensing at different stages. The temperature आहिस्ता आहिस्ता drop होता जा रहा है. And at the very top, you're going to get petroleum gases. Okay? There would be things, when it reaches room temperature, they will still not condense. And those are your petroleum gases. You need to know the order and the uses of all of them. Here I told you, okay, cracking is done. That big molecules are not very useful. You can't really burn them properly, like waxes, petroleum jelly, bitumen, tar, etc. The big molecules. So what you do is you add a catalyst and high temperatures. It'll be high temperatures, like the thing you add a catalyst and you have temperatures that are well above 450 degrees centigrade. So they're greater than 450. So the molecules collide violently with each other and they break down into smaller pieces. The smaller pieces are basically smaller alkanes, alkenes, and hydrogen gas. So you're going to get a mixture of this. So you might be given, in the paper, you might be given a big molecule and you might be asked to crack it. So remember, it could be any small molecule could be produced. For example, they might give you a C60 H122 alkane. Remember, alkanes have a general formula of CN, H2N plus 2. So if you have a big molecule, what you have to do is you're going to crack it into smaller pieces. Now, those smaller pieces could be, it's up to you. It could be a 10 carbon atom molecule. It could be a 20 carbon atom molecule. So you get 30, and let's say there's a 30 carbon atom molecule. So the molecule will break down into smaller pieces, and they could be alkanes. If it's an alkane, so CN. H2N plus 2 means that the number of hydrogens would be double plus 2, so that's 22. Over here, it's going to be 2N plus 2, so the double it plus 2, so that's 42. And this would be double it plus add 2 to it, and that would be, so that would be 62. Anyways, the next, so the point is, the idea is कि भाई आपके पास है, you're getting these molecules. You broke it into smaller pieces and you got a bunch of alkanes, alkenes. So you're going to get a bunch of alkanes, alkenes, and or hydrogen gas. It's not important that all of them are obtained. Remember, the general formula of an alkane is CnH2n plus 2. The general formula of an alkene, alkenes have double bonds in them. So that is 2n or hydrogen gas. So if you look at what I've done, the only thing you have to make sure is, if the big molecule breaks down into smaller pieces, then the smaller pieces must add up to be equal to the big molecule. So 10 carbon atoms, 20 carbon atoms, 30 carbon atoms. In total, that would be 60 carbon atoms. Hydrogens must add up to be the same as well. So 22, 42, and 62. So this would be 104. Plus, if you add 104 22 add, you're getting a lot more hydrogen atoms. This would not work. So you would have to reduce the number of hydrogen atoms. So what if I make it an alkene, C10H20? What if I make this an alkene as well, CnH2n? So this would be CnH2n and I keep that one of them as an alkane. So now if I add up the hydrogens, it's 20 plus 40 plus 62. That would give me 102 plus 20. That's exactly 122. So the idea is you have this big molecule and you're going to break it into smaller pieces, and it's up to you. Whatever piece you want to make, you can break it, as long as it fits the formula of an alkane or an alkene or a hydrogen gas. Okay, the molecules are going to bump into each other, and they're going to break into randomly. They're going to break into a lot of smaller pieces. लेकिन वो formulas जो है, they must make sense. I mean, it's either an alkane, alkene, or this thing. So I could have cracked it some other way as well. Maybe I could have cracked it into a molecule with 40 carbon atoms, another molecule which has 20 carbon atoms. And both of them are alkenes. So this one would also be CnH2n. So it would also be an alkene. So the molecules must add up to be equal to this. So I've broken it down into smaller pieces. But if you look at the molecules, it's not adding up to be equal to this. It's 60 carbon atoms, but the hydrogens are in total 120. So there are 2 hydrogens missing. So what I'm going to do is, I had an option of producing hydrogen as well. So I'm going to add in H2 gas as well. So bas jo bhi karo na, that is, you take this big molecule, break it into as many pieces as you like, as long as they are a mixture of alkenes, or hydrogen gas. And the total must be equal to the original molecule. Yes, sir, clear? Why is this clear? Sneem, Hamza? Zainab, is this clear?
Yes, sir. Yes, sir.
Achha, so just remember, it's not important that all 3 are made. It's up to you. As long as the conditions met, the things must add up to be equal to this. So I'll do just one more. Okay, I'm going to crack it. And I'm getting a 15 carbon atom thing. I'm getting a 30 carbon atom thing, and I'm getting क्या पीछे बचा है 45, so I'm getting a 10 carbon atom molecule and I'm getting a 5 carbon atom molecule. So I think that's a total of 60 carbon atoms. Or let's make this an alkene. So let's make this one an alkene as well. Let's make this an alkane. So this would be double it and plus 2, 22. And let's make this an alkene. Though the molecule has been cracked into all these pieces. अब ये के अच्छा, अब ये के क्या करना है इसका कि I just need to check, is this which is missing to नहीं? That's 30 plus 60, that's 90, 90 plus 20, 90 plus 10 is 100, 100 plus 22 is 122. So it's exactly, we're right on point. Okay, this is 122, so this is fine. So that's it. That's about cracking, okay? And remember why it's specifically used. कि बहुत सारे जो बड़े molecules हैं, they are not very good. So just hold on 1 minute, azan हो रही है. उतनी देर में लिख रहा हूँ, ठीक है? let's start with reactions of alkanes. ठीक है, तो alkane क्या था? Saturated hydrocarbons are all single bonds. So any alkane that you draw, if you have 4 carbon atoms, that one is going to be bute. It's going to be butane. Butane means bute means 4 carbon atoms. So that's another alkane. General formula likha hua hai. So C4. H would be 2n plus 2. That means double it, and 8 plus 2, that's 10. So you can count it. That's 10 hydrogens. So this is what an alkane is. So first thing is very quickly going through the physical properties of alkanes. So there are two main physical properties. One is that they've got low melting and boiling points. And the second property, main important one, is that they are insoluble in water. But they're soluble in oil. So they're very soluble in oil, but they're insoluble in water. So those are your two main physical properties. Remember, okay, if size increases, so this happens to every hydrocarbon. Whenever the size of the molecule increases, what happens is the melting and boiling points would also increase. The viscosity would also increase. It would become more thick and it would flow less easily. And size increases, so flammability decreases. They become less flammable. So this always applies to any organic molecule. That's what alkanes are. In reactions, you don't have a lot of reactions for alkanes. Mainly the reaction that you have is it's a simple reaction where what happens is it's a photochemical reaction, and it's known as chlorination or bromination, depending who you're reacting it with. Also known as substitution reaction. अच्छा, ये सारा है. अब इसमें ये कि what is this reaction? The reaction is simply it's a photochemical reaction, which means photochemical reactions are those reactions.
Sir,
हाँ जी.
is BO2 liquid?
Which one?
BO2.
नहीं, मुझे नहीं समझ आई, क्या कह रहे हो?
Sir, is BO2 a liquid?
हाँ, Br2 is a liquid, ठीक है.
Okay.
अच्छा, okay, photochemical reactions. It's a photochemical reaction, which means UV light is very essential. Now, what happens is you take an alkane, and when you have an alkane with you, and this one is 3 carbon atoms, so it's propane. So this is what goes down. You react it with Cl2. Cl2 is a diatomic molecule, and you need UV light for this. So it's UV light or simply sunlight. So you need sunlight for this. And a simple reaction happens, and what happens is it's known as a substitution reaction. One of the H and the Cl, they combine to form HCl. So they end up turning into HCl. And what is left is they join up. So let's just copy this. So what is left? It's simply, they simply join up. Remove the H and Cl from the middle. So they're gone. And this Cl over here, it will come and bond with this carbon atom, making the fourth bond. And that's a substitution reaction. So every time this happens, that the simple thing is one of the H in the propane molecule is going to get substituted by Cl. And it could be any H. So if I just copy this reaction, so what I can do is I can make up another reaction where the same thing would happen, except a bit differently. Like you could have this one. So you have this molecule. So the chlorine molecule is going to come in, and there could be many chlorine molecules that could actually show up, not just one. So here's another chlorine molecule coming from this side, and the chlorine is going to combine with one of the H atoms. It's going to steal one of the H atoms. So in this case, two Cls are going to be formed. Two HCls are going to be formed. तो यहाँ पे आपको दो HCl के molecules मिल गए. ठीक है, two HCls are getting formed, and the H that have bonded with so these H over here, they're going to go away. The H and Cl are gone, and this Cl would now come and bond with this particular carbon atom, the two carbons that are not making complete bonds. Okay, so it could be any hydrogen that could be attacked by a chlorine molecule, but UV light is essential. So whenever you see an alkane, the products could be that any of the H would get substituted. So the simple thing that's happening is that so if I draw ethane, then you're going to get many different products for this, because any of the H could get substituted. So यहाँ पे let's say this Cl could get substituted, or maybe these three H's could get substituted by Cl, or there's a possibility that all of them might get substituted by Cls. So all of them might get substituted by Cl. So whenever you have a reaction with Cl2 in the presence of UV light, so every time you get this product, and the byproduct in this reaction would always be HCl. You can balance it, you can increase the quantity of HCl that are getting produced. So if there are three hydrogens getting substituted, that means there would be three HCls getting produced. If there's only one hydrogen getting substituted, so that means only one HCl would be produced. And if all of them are getting substituted, that means 6 HCls are going to be produced in the reaction. So you need Cl2 plus UV light, and any of the H could get substituted. Ye clear hai? Hamza clear? Nawal, Sadeem, is this clear?
Yes, sir.
So that's pretty much the only reaction that alkanes undergo. That's it. Okay, so you just have to remember this reaction. That's it. It's a photochemical reaction.
Sir?
Yes.
if it's Cl2, only one H will be substituted, and if it's like two Cl or like three Cl, then there'll be multiple.
But the thing is, in any reaction, it's not just one Cl2 that's reacting. Like over here, there's only one Cl2, right? Over here, there's two Cl2s coming in. So the point is, in any reaction, you don't have just one Cl2. You add a lot of Cl2s, right?
Okay, sir.
So it depends. It's a random reaction. Maybe only one of the H might get substituted. Maybe two of the H's could get substituted. Maybe.
And sir, the amount of H substituted depends on the number attached to Cl. It's not like depending on the Cl2, right? Like if it's just Cl2, it'll just be one. But if it's two Cl2, then it'll be two.
Exactly. Okay.
Okay, sir.
Okay, one of the Cl gets wasted because it reacts with the H to form HCl.
Okay, sir.
Okay. So the point is, and this is the structural formula. You might be asked to write just the molecular formulas. So this is all you have to do. For example, they might ask you to write a substitution equation for the substitution of, let's say, butane. So butane is what? Butane is, according to the formula, but is 4 carbon atoms. So it's C4 and H10. Okay, the general formula is 2n plus 2. So that means it's double plus 2. So 4 into 2, 8, 8 plus 2. You reacted with Cl2. And butane would become C4H9 because one of the H got substituted by Cl. And that H ended up forming HCl. So you might be asked to write that equation as well. So the thing is that I said, what is produced? What do you call this thing? This is known as a Chloro Ethane. Because it's got it's an ethane with, I mean, 2 carbon atoms, that's eth, and it's an alkane, but because all are single bonds. But since you have a Cl, so you call it a chloroethane. This one would be trichloroethane. This one would be hexachloroethane, or simply we'll just call it chloroethane. Similarly, this one would be dichloropropane because it was propane, but now it's got 2 chlorines as well. So you would call this dichloro, means there are 2 chlorines. And it used to be a propane. So it's now a propane with 2 chlorines. And similarly, this would be just chloropropane. That's it. So that's it. That's substitution reaction. The next thing we're going to do is we're done with alkanes. That's it. TK, that was pretty much the only reaction. As you always have a combustion reaction. So I'm going to talk about the combustion reactions in one go right at the end, because all hydrocarbons have pretty much the same combustion reaction. So combustion reactions, every hydrocarbon undergoes that. अच्छा पिछला clear है alkanes, ठीक है, we're done with alkanes. Is this clear? Zainab, Saneem, Nawal, Hamza.
Yes, sir.
So now we're going to move towards, okay, now we're going to move towards alkenes and look at the reactions. Okay, we'll be done with organic very quickly. Okay, we just need to know these reactions. Then we're going to try and build a table, a chart on how to memorize all of this. So alkenes, what were alkenes? They were your unsaturated, they were still hydrocarbons, which means that they only had, hydrogen and carbon, but they were unsaturated, which means that they had double bonds. So for example, this was the first one. This was ethene. Because it's got 2 carbon atoms, that's eth, and the name would end with ene. And then we discussed, okay, when you move towards bute, which is 4 carbon atoms, there's an issue that you have to tell them exactly where the double bond is. So this one will have 2 H's, this one will have 1 H, 2 H's with this, and there would be 3 hydrogens with this one. So this one has 4 carbon atoms, that's but and ene, but you have to tell where the double bond is. It's at carbon number 1. Okay, you count from the side that gives the smaller number, so it's but 1 and ene. So it's butene. And the so that's it, that's alkenes. Okay. Now all alkenes, they undergo kind of the same reaction, which is called I mean, they have a lot of reactions. इसमें मैं वो add कर लूं कि with alkanes. Okay, they kind of, let me add this, that alkanes don't undergo a lot of reactions. They are pretty much unreactive. Alkenes, on the other hand, are really reactive. So alkenes are very reactive. And so the reason alkenes are kind of very reactive is because they've got double bonds. These double bonds are very reactive. So all alkene reactions are known as addition reactions. So all alkene reactions are basically known as addition. So whenever they're going to, I mean, the previous one was substitution, but now it's, for alkenes, it's addition reactions. अच्छा, अब इसमें ये कि all alkene reactions addition. I'll just first tell you briefly what happens whenever you have an alkene. So whenever you have an alkene, you're going to have a double bond somewhere. And you're going to have a bunch of atoms attached to around the double bond, whether it's hydrogen or carbon or whatever. This is what an alkene would look like. It's always going to have this double bond, whether it's this molecule, or any other molecule, it's always going to have double bonds. The reactions are going to look like this. Let's say it reacts with a random molecule known as XY. So what you're going to do is redraw the alkene as it is. Okay, let me add hydrogen atoms to this just to make it. So let's take the example of ethene. So everything would remain exactly the same. Okay, ethene ki bajaye, let me add a carbon over here. So here's my ethene. Molecule. और अब यहाँ पे क्या होगा कि all reactions for alkenes, ठीक है, now listen carefully, all reactions of alkenes, they happen with this double bond. I mean, nothing happens to the rest of the molecule. The rest of the molecule pretty much remains exactly the same. The only thing that happens is that these 2 carbon atoms that are part of this double bond, this one and this one, their double bond breaks and it is replaced by a single bond. So all reactions, whenever it reacts with something, for example, some random thing X and Y, the double bond is the only part that is taking part in the reaction. The rest of the molecule remains exactly the same. So what you're going to do is you're going to redraw the whole molecule as it is, except that the double bond would change into a single bond. And the carbons are now short of 1 bond. And this carbon is also short of 1 bond. So what happens is that the atom of X comes and attaches to this carbon atom, and the atom of Y comes and gets itself attached to this carbon atom. And that's it. Every time you're going to have this reaction. And let me circle this just to highlight this. So every time you're going to have this reaction that there's a double bond, And when you have a double bond, it turns into a single bond, and whatever molecule it's reacting with, X or Y, something, some random molecule, the molecule is going to get itself attached to these two carbon atoms, and the double bond would disappear. Okay, that's the main idea of the reaction. So all the reactions we study after this would follow the same path. Is this clear? Is this clear? Yes or no? Is this clear? Hamza, clear? No. Nawal, Saneem, is this clear? So the first reaction, reaction number one. Remember all of the reactions that we study from now, that they would be called addition reactions. So reaction number one is known as bromination. So in bromination, what happens is that you have an alkene and you react it with bromine. So let's say I have an alkene, a but-2-ene molecule. But means 4 carbon atoms. This one will have 3 H's. This one over here will have 1 H. This one will have 1 H as well, and this one will have 3 H's. So that's a butene molecule. I'm going to react it with a bromine molecule, which is going to be Br2. Now remember, the whole reaction would be with this double bond, not with any other thing. So the whole reaction would be with this double bond. So what's going to happen is, just as I explained above, कि भाई आप molecule लोगे, उसको उसी तरह draw करो, except that instead of this double bond, you just now have a single bond. And the molecule, which is in this case is bromine, is going to get itself attached because carbon needs a 4th bond. So one bromine gets attached over here and one bromine gets attached over here. So you're going to get these circles mein वैसे ही बना रहा हूं just to highlight. So it's an addition reaction. The bromine molecule gets added to these 2 carbon atoms. That's it. So which is why it's called an addition reaction. And that pretty much sums up the reaction. That's a bromination reaction. So whenever you see an alkene, the bromines are going to get added to it. Let me write the conditions as well for this reaction. The conditions are, you need Br2 aqueous. That means dissolved in water, or Br2 in inert solvent. Like CCl4. And there has to be absence of light. Because right in the previous reaction, we studied that in the presence of light in alkanes, you get these substitution reactions. The hydrogen atoms, they get substituted by Cl or Br. It was a reaction of chlorination or bromination that could happen in the presence of sunlight. So in the case of alkenes, you don't need sunlight. You don't want the bromine to react with the hydrogen atoms. You want it to react with the double bond, which is why the bromines, all of them are going to get added to the double bond. And absence of light is required. So I'm going to do some more complicated molecules. Okay, let's say I've got so let's say I've got this molecule. So this one will have 1H. Every carbon atom should be making 4 bonds. And this one will have 1H as well. So anyways, this is the molecule. I'm going to do bromination of this reaction, of this molecule. So it's a big molecule and it's reacting with bromine aqueous in the absence of light. And let's see what happens to this molecule. So the molecule would remain exactly the same except for these parts. These parts, the way you have these double bonds, bromines are going to get added to these double bonds. So bromines are going to get added to it. So you just draw the whole molecule, copy it again, draw it over here, get rid of the double bonds and start adding your bromine. So carbon are now short of one bond. So you're going to add one bromine to this one and you're going to add one bromine to this other carbon atom. Same goes over here. The double bond is now gone. And one bromine gets added over here. And the other bromine gets added to the next carbon atom. Okay? Ye clear? Is this clear? Hamza clear? Zainab, Nawal?
Gotcha.
Yes,
So,
sir.
so just remember, this is just the first reaction. Okay? All alkene reactions would be exactly the same. You see the double bond. Next time you don't see the double bond, you see a single bond in its place, and the carbon has to make extra bonds to complete its 4 bonds. So bromination has some certain significance, and the significance of this reaction is that this bromination reaction is used as a test for identifying alkenes. So it's used as a test for identification of alkenes, because whenever you want to check whether there's a double bond, what you're going to do is you're going to add bromine to it. And if there is a double bond, the bromine is going to go and react with it. So it's a test for identification of carbon, double bond carbon, basically unsaturated molecules. So it's a test for, and what happens in this test? That if it is a double bond, so what happens is that the red, orange bromine, red, brown, or orange bromine, it disappears or decolorizes because it gets used up, it reacts. So that is the result of this test. So it's a very important test which is frequently asked in your past papers. So whenever you want to identify or differentiate whether a molecule is unsaturated, it has double bonds or not, you react it with bromine. The bromine is going to immediately go and react with the double bond and add itself to it. So there's an addition reaction that would happen, and the red brown bromine will eventually get decolorized. Okay. So इसके alkenes के ना बाकी reactions we'll try and quickly go over them. I'm more interested in past paper questions. So we're going to try and finish the reactions very quickly. So this is bromination. This is the significance of bromination. The baki addition reactions of alkenes we'll do tomorrow. Okay. So okay, everyone. Take care. Allah Hafiz.